Hello students, and welcome to this lesson on inverse trigonometric functions. Our objective today is that we will use trig ratios and inverse operations to find the missing angle of a right triangle using journal notes and a practice worksheet. Now, we're all aware of the trigonometric functions. You have sine, cosine, and tangent. And we know that sine, cosine, and tangent, the input for these functions is some theta, or some angle. And then the output is some ratio. Maybe it's the adjacent side over the hypotenuse, maybe it's the opposite over the adjacent. You get the deal. So we know that if we say the sine of some theta, where our theta is our input, then our output will be the ratio of the opposite side over hypotenuse. So my output is some ratio. And the same thing happens for cosine and for tangent. So this is important because now we're going to define the inverse trigonometric functions. So the inverse of a function is the function which undoes, right? It's something that will do the opposite of what the original function did. So in this case, now we're going from some ratio to an angle. So now, instead of having my input be an angle, my input is some ratio. And my output will be my angle. And the way that we denote an inverse function is that we're going to write sine, but now we're talking sine -1, right? So this is the inverse sine function. So that's the key difference here, is that this is the inverse sine now. An inverse sine takes some ratio as its input, and it will actually take an input of an opposite over my hypotenuse, and my output is going to be my theta, which is associated with that. Likewise, we can write the inverse of cosine, and the inverse cosine is going to be cos -1, and then our input is going to, again, be a ratio. It's the ratio of the adjacent over the hypotenuse. And then that is equal to some theta. And then finally, we have our tangent. And our tangent, the inverse tan, is tan -1, and our input is going to be the opposite over the adjacent side, so I have to have both sides as the input, and then I can write this as equal to some theta, where theta is an angle. Now, to access these functions in your calculator, you're actually going to press your second button, right, and it's the blue button. So if you want to get the inverse function of those original buttons, then you see that they're actually associated with each other on the calculator. So if you press the second button and you press the sine, you see in blue it says sine -1 up there. So that'll give you the sine function, or the arcsine function. We sometimes will call it arcsine, we'll sometimes call it the inverse of the sine. So this is your inverse trig functions, and the purpose of them is that now, given two sides, you can actually find an angle. So let's look at some examples of this. Okay, so our first couple examples is we're going to actually just look directly at our numbers that we're using. So we're going to say A, B, and C, and we're just going to practice putting these in our calculator. So we have the sine -1, or inverse sine, of some ratio, right? 0.4848. So remember that a decimal is still a type of ratio. All right, and then we can see that our output is going to be 29 degrees. So our input was 0.4848, and then our output was 29 degrees. And then we can do the same thing with cosine and the same thing with tangent. So then we have cosine of -1. All right, so now let's see what this looks like as far as a starting state for a problem. So if we're starting with the sine of theta is equal to 40 over 42. So then what we can do is we're going to try and solve this problem for theta. So I've identified that I'm looking for theta, right? Theta is going to be my output. My input is going to be 40 over 42. So I'm going to take the inverse sine of both sides. So I know that the inverse sine of both sides will cancel out these functions on this side, and on this side I'll get the sine minus 1 of 40 over 42. So then I'm going to have sine minus 1 of 40 over 42 is equal to some theta. So now I can plug this into my calculator and I can actually solve for theta. And when I plug this in, my output is going to be 72.25 degrees. And a lot of the times we're going to approximate that to 72 degrees because it's hard for us to actually measure a 0.25 of a degree. Alright, so for you guys, what we're going to do is there will be another video that will go through the examples of 3, 4, and then we're going to do a 5th example as well. So once you're done with the video, go ahead and write this into your journal. You've got these 2 triangles here, and then we're going to have example 5 that will work together. Your reflection for today is going to be what type of input is used for an inverse trig function. What type of number is the output? So what is the type of the input and what is the type of the output? Alright, have a wonderful day, and to do the examples, go ahead and look for that other video. Goodbye.